Interpenetration of solids. Two solid pieces here that we're going to have joined with each other so that you can see where the connection is. Circle that we're going to turn into a 3D object, and a square slanted 45-degree angle that we're going to turn into a 3D object. Using this frame for alignment, just showing you the principle behind the whole interpenetration. Select object, 3D rotate, select the plane on which you want to rotate. So I turn it vertical. I'm going to move it now over to let's try to move again. Let's turn off ortho. Alright, there we go. Alright, so if I right click on 3D orbit and go around the object, you can see what we're working with. Now let's extrude these two shapes into 3D objects so that you can see where the two objects will intersect with each other. Select your circle and type extrude. Once you select extrude, it will give you the option of changing the height of the object to a 3D object. For this one, for my example, I'm using 300. The figure will differ depending on what you are doing. Doing the same thing to the square that is slanted 45-degree angle to look like a diamond. Type the same thing, EXTR. Extrude, good. By 300 as well. And there we have it. Go back to 3D orbit and rotate around the object. Now you can see now I have a cylinder and a cuboid that we're going to have intersect with each other. Switch our view to conceptual. You'll see the objects in solid view, or even better, shaded with edges. Gives you a more realistic concept. Now I'm going to switch this to my layers. In layers I have solid 1, solid 2. I'm going to make the cylinder solid 1 and cuboid solid 2. I'm going to take this object now and move it. Where do I move it from? Let's just move it along that plane. Keep the ortho on. Turn off the snap and just move it till where it touches the object. Okay, good. Now, looking at our object once more, there was something off with the alignment, but here we have the cylinder being intersected by another object, and we're going to switch to top view and go back to 2D wireframe to see the object. So you'll see something like this in the textbook. What we're looking now is from the plan. If you're given this object, you can now draw the front view from this. So just turn on zero layer. We're going to use the zero layer as our construction lines. And so your construction lines can be tall, like so, and with the line tool I'm just going to create a base point to start from. Alright, just project some lines from the edges. My circle is 100 wide, so I'm going to offset this by 100, so 100 to the left and 100 to the right would give you now these two lines that show you the width of the circle. And if I now also offset this line by the height of the cylinder, which is 300, then I have that. Now let me show you what we're really trying to get. These two lines, switch them to offset, and I'm going to now use a line tool, switch to solid 1, and using the line tool I'm going to trace out the polygon, or the shape of the polygon. Let me turn on intersection. Okay, great. Also, what do I know about this object? Let's go back to 3D orbit. I also know that the cuboid here is 100 millimeters from the base. So from the base here up to the bottom of the cuboid is 100 millimeters. So if I were to switch the angle, then I would be able to measure now. That's what your side view would look like. So let us measure this distance, which is from here to here, being, what is this, 141. All right. We're back in our regular view. Let's just trim out some of these lines that we don't need for now. Or know what, let's leave them. Using the line tool, I'm going to draw a projection line of 45-degree angles from here out to as tall as I need it to be. Leave that, and then let's just draw some new lines now that will also project from intersection point here, and let's turn on back our ortho to keep in line across. There'll also be, let's extend this line down so we can find the intersection. Light in, cross. So what I'm doing is trying to project lines from every significant point of the object. This one is already there, so I'll just stretch it. And so what, notice now I have a line from the outside of the circle, from there, or from the highest point of the circle to the lowest point of the circle, and I have a line from the top of the square down to the bottom part of the square or rectangle, and I have a center line. So I have all these 5 lines that are intersecting with my projection line. So what I'll do is trim and enter once more to kind of get rid of these, that, and that. Also, I might need to extend some lines. Extend that one out. Let's extend that one out, and let's continue now projecting. Now what we're projecting is from the circle off to where this line intersects with a 45-degree angle, continue upwards, tall, not sure how high, but let's just make it tall enough so we don't run out of line. From here upwards. Now, as we said before, I know that let me go back to that view. Looking at this, I can tell that from the center of the cuboid down to the base is 241 in this example. You can use a solid rounded number to make it easier for you. Going back to the top view, I can now draw a line from here upwards. That's 241, and that line now that figures off. Get it properly. There we go. Alright, so going up by 141 because that's the height of the center of the rectangle, and if I go outwards a line and stop out there, then I have the center of my rectangle. Now the rectangle must fall between here and here. Alright, when you use the fact that the object, I'll show you from 3D view again. The object, if you look at it from this way, look at the pink lines only. You notice this is equal distances. This side, that side, that side, that side. All four sides, 5 sides are equal. So the distance from here, distance from the left to the right, would also be equal to the distance from the top to the bottom. So knowing that, we can recreate the object from the view that we want. So whatever width this is also the width here, and also will be the vertical distance. So what I'll do is, let us switch to a pink line, and using the line tool, let's draw lines in between. Why is this not intersecting? The lines are not touching properly. Let us fix that issue. Alright, so our issue has been sorted out. So let us pick up from where we stopped. Now here we have our object. We're just going to identify the width from where the cuboid would start, meaning from here to here would be the horizontal diagonal, and if we rotate this line from its center, from center axis, rotate it vertically, then we have a line that we can use now to identify where. Let's show you then. Here to there, and there, there, there. So what I have now is the same object showing you front view. I'm going to take this now. And use this to now project lines across. Lines across. And let's go back to our zero layer. Using a line tool again, identify how far out the object could stop with the line there. Very good. So let us do some trimming. That, and I'm just trying to get rid of some lines out of the way so you can see better what the object will fully look like when you've gotten all three views. Alright, so let's switch back to the solid layer and finish tracing out. Side view, and just switch to the green there, which is solid 1, and trace out the cuboid from this side. What we're really trying to get is front view, top view, and side view, aka end elevation. Alright, so I think that should suffice for all three views. Just a little bit of trimming and editing here. This line, let's trim some of this. But before I do that, yeah, let's trim some of this to get rid of that pink line there, and replace them with white lines from the solid layer. If I connect, I'm just going to reconnect those that I deleted because I wanted to change the transition in color for understanding's sake. Alright, cool. So if I were to turn off the zero layer now, you should have been left with the three views. Let's turn the current off, yes. Good. So this is what you'll end up with. And this line here, we can delete that. What you're seeing now is the same object from above. You're seeing the top of the circle at the top of the cuboid that we created. This is the same object from the front. This is the side of the cube, and side of the cylinder, sorry, and this is the side of the cuboid. What we don't have is we're not sure how to draw this curve that would show the intersection between the object, and this whole activity is just to create this line here. And over here now what we have is the same object showing now from the side view. Alright, let's go to 3D rotate or 3D orbit. Cool. And let's make copies of the two solids that we're working with as a sample. Alright, select C O P C O P, select, and I'll copy it from the base, and I'm going to move it away by a distance of probably 800. So I know how far it is. If I want to put it back in place, I can. Now if I were to switch back to this view, let's explain what we have now. Everyone should be able to already understand what top view means, or plan view. From 3D orbit, if you're looking at it from above, all you'd see is circle and the top of the cuboid. If I were to switch in front of it, all you would see is something that looks like a square, but it's not really a square. It's just because you're at the side, as if you were standing in front of a bottle looking at the side of the bottle. You would see something that looks more rectangular, but if you were to start to move around it now, you'd start to see that it's actually round from one side. So there we have front view. And what would side view look like? Now let's go over to the right side of it, and what you end up with now is just the same rectangular shape representing the cylinder, and a diamond in the middle that represents the cuboid that's intersecting. Now the assignment or this activity is asking you, what would this curve look like? This is where most of your marks would come from. Being able to trace out the pattern of the intersection, as the topic it says, is interpenetration of solids. And so we have solid 1 and solid 2 being intersected, and your objective now as a student is to find how these two solids will intersect and trace out the meeting point between the green and the pink solids in this scenario. You don't have to create 3D objects when you're doing the activity. The 3D objects that I'm creating now is just to give you a realistic understanding of what you're really seeing. Now going back to top view, you can remember that's what we saw when we were at the side. Same thing that we drew there. From the top, self-explanatory, and from in front of it, if I was to shift in front of it, you'd see that. And so that's what we're drawing. All right, let's go back to our regular view and turn back to 2D wireframe, so it looks like your regular drawings. And if I were to go back and turn on the zero layer, you end up with a bunch of lines that creates a confusing scenario. You're wondering why all of these lines are there, but it is just to get you to be able to cast or project dimensions from one view to the other view. Alright, important parts of this: the 45-degree line must start from this central point here, right at the base of the object. 45-degree line would start and project either to the left or to the right, depending on what angle you want to project from. But either way, the 45-degree line must be connected to the front view. Alright, now I'm going to turn off the zero layer for now and go into the important section of the drawing, which is really to find how the curve here would look. So what I need now is to identify some important parts. So maybe I'm going to need the zero layers anyway. Alright, let me try to create them without it. I'm going to switch to another layer of a different color. Let's use the plan view line layer that has yellow lines instead, and let's see if we can recreate the scenario. Alright, so this point here that I'm highlighting now would be the same thing as that point there. So we already have the top or the highest point and the lowest point of the curve, right? You know what, for understanding's sake, let me rotate the 3D object so you can both see it. Alright, so I'm going to take our sample over here. Let me go into a view that's easier to see, 3D orbit again, and this 3D view. And for clarity, let's change it to a view that we can easier see. Take this object and take that object, and let's type in 3D rotate. 3D rotate, I'm going to select the plane that I want to switch to, select that, and I'm going to turn it 90 degrees that way. Let me try that again. It did not function properly. Alright, 3D rotate, and I'm going to select the plane that I want to rotate it to, and I don't want it, I want it to flip. Come on, 90 degrees that way, that's down. 90 degrees forward is the same direction. There we go, and click. Good. So if I take this now and move them a little bit closer to where we want it to be, there we go. Good. So when I go to the top view now, you'll be able to have a one to follow. So as you can see, this is still the front view, and what we're trying to draw now is this curve pattern. Now the sequence is a bit confusing, so focus is important for this section. We are going to now project some lines or Euler layer is already selected, so with the line tool I'll find the midpoint or the side view of that and just go across with it. I'm not sure how tall it goes, so let's leave it there. And also, if you notice, if you notice this line here, these two would meet here. Let me switch back to the regular view, where the top of this circle, where these two meet, is a section that you might need. Alright, let me turn this off. Alright, just pause there to do a little bit of editing to reduce some of the confusion. Alright, so we have now an object here that we're trying to identify where the curve or the intersecting point is, as we said before, right at this curve. So what you have now is this diamond shape here would show that this is the height. Right here is the highest point of the intersection, and this part would be the lowest point of the intersection. So let's just turn off the horizontal layer to get rid of some of these lines that we don't need, and switch to our plan layer. And using some lines, let us now project to show where the lowest point would line up with. If you draw across, you realize that it's the same thing as right here, same thing as that point there. And the top here will line up right back to this point here, so that's the same thing. So what we have now is highest point, midpoint, lowest point. On the 3D version, highest point, lowest point, midpoint. But how do we identify the midpoint? Notice that the midpoint is not vertically aligned with the highest and the lowest point. It's a bit further back. So, alright, so this is where we're at, ladies and gentlemen. We have all three views, or top view, or plan, front view, and end view, and we would have labeled them as such. Example, with our title with the names meaning plan, front, and end. Also labeled are the points at which the 3D object has intersected. This part here, as we're highlighting, is the top of the cuboid, which intersects right here with the cylinder. That will be labeled as point A, as you can see in our front view. On the end view, how do we identify that point? If we draw a line right across, you realize that it is the same point that is touching here, and so that part is also labeled A. Following the same sequence, the lowest point of the connection, or the lowest point of the intersection right here, if you notice on our front view, would also be labeled B, and subsequently will be also labeled B on the front view, or on the end view I should say. Now, how do you label the sides? The sides, if you look here, both the left side and the right side are in line with each other. That means both of them will be hard to distinguish from each other, but both of them must be labeled still. So on the left side we call D, and on the right side is called C. But if you turn to the front view, you won't be able to differentiate between C and D anymore, because both lines are now lapped over each other or intersecting with each other, but nevertheless the labels are there for those who would understand. Let's see how the labels work with the plan. This time on the top view, looking down on the object, you can identify right and left being C and D, but this time it is the top and bottom that are in line with each other, and so you won't see A and B as two separate lines anymore, you'll see them as one. Alright, now with that out of the way, we now need to identify or create a pattern that we can trace out to get the curve. The curve will be shown here like so. How do we get this curve or this pattern? there's a sequence that you must follow. First, let's turn this off to get it out of the way until we're finished with the pattern. Alright, so we have now our construction lines which we'll follow. Here are a bunch of lines that may seem confusing, but this is an important part of it. The 45-degree line that we had before is important. We must maintain it. And then from that now we create some radial lines. These radial lines start from the center of the circle and protrude outwards, as you are seeing demonstrated in the example. The angles at which they are projected could be 60 degree, 45 degree, and 15 degree or 30 degrees. Nevertheless, what is important is that they are equal to both sides. Now, for this particular example or for this particular activity, you may not need the lower section of the radial lines. You may only need the midline and the upper section of the radial lines, meaning line 1, or I should say line 3, line 2, and line 1. Line 1 here would protrude and travel around to the 45-degree line, where it will then move upwards. As it goes up, it shows you, if you notice, line 1 is intersecting with AB, meaning the highest and the lowest point. So line 1 is showing the highest and lowest point of the cuboid, and if you follow the path over to the end view, you realize that line 1 is touching the highest point and is at the same time touching the lowest point. Let us turn on our labels. Line 2 now would travel across and upwards. Line 2 will now touch the diamond shape, or would touch the cuboid at 2 points, lower and upper. Lower would be 2 and upper would be 2A. Both these contact points would protrude across and be labeled 2 and 2A. Let's follow line 3. Line 3, as usual, would go across, touch the 45-degree line, and then be protruded upwards. Line 3 goes up and touches the cylinder, not the cylinder, touches the cuboid at 2 points, right here and right here. These 2 points, to differentiate them from each other, will be labeled 3 and 3A. And if you follow the path, they go across and go across. Now, if you notice, my numbers here are already laid out in the pattern or the shape of which the curve that you're trying to get. How do I know how far out the number should be? If you turn on my other lines, I have a set of lines that also protrude upwards. From line 1, I had a line that went across. That's yellow. And also from line 1, I have a line that goes up. That is red. Same thing with line 2. Line 2 has a yellow line going across and a red line going up. Line 3 has a line across and a line goes up. Line 4, which the label is missing here, but line 4 has a pink line that turns into a yellow line going across and a red line up. Let's follow the meeting points of these lines now. Line 1 would be here and would remain as they are. Line 2, however, is the important part. Line 2 would meet with the cuboid and start across and also meet up with line 2 from below. As down here, there's a red line that starts from 2, goes up and will meet with the yellow line from 2 that went all the way around and came back to this point. So that is the intersection that I use right here. Now, line 2, as we said before, touch the cuboid at 2 points, at 2 and 2A. If you follow the pattern now, 2A would be up here and also go over to touch line 2. Line 3 follow the same pattern. Line 3, yellow line goes across, upwards, and touches the cube at 2 points. Those are labeled 3 and 3A. 3 goes across and touch red 3. 3A goes across and touches red 3. And that is the intersecting points at which I put my numbers. Let's see what line 4 does. Line 4 goes across, goes up, and meets only and touches the cuboid only at one point. It only touches at the end. And so only one line is protruded across. And how far does it go? It reaches over to line 4. So yellow 4 goes all the way around to come and intersect with red 4, which goes directly up, and that gives you my midpoints. So what I use now is to turn on the spline tool and zoom in to the intersection of 1 and 1, move over, click to the intersection of 2 and 2, intersection of 2A and 2, intersection of 3A and 3, intersection of 4 and 4, intersection of 3 and 3 again, to the intersection of 2 and 2 again, and back down to the intersection of 1 and 1 again, and enter, and then you would have gotten the curve. From that, now you can go back and turn off the construction lines that you won't need, like the red lines and the yellow lines that you don't need, and you're now left with the final object. At this point, you may need to do some trimming, like this blue line would need to be switched to that layer to get rid of it, and you may also need to trim the midpoint here to show the proper sections. And there you have it, the full interpenetration of solids with a cuboid and a cylinder. This section is very critical, so it is important that you realize that the number sequence, number 1 starts in the middle and goes outwards, and with this one, number 4 starts in the middle and goes outwards. So here we have number 1, 2, 3, 4. 1, 2, 3, 4. With the front view, it is 4, 3, 2, 1 and 4, 3, 2, 1. To complete the drawing, you also may need dimensions, which you can use the linear dimension tool to add dimensions. In my dimensions, I am showing important part sections only, meaning the total height of the cube, total width, not cube, total height of the cylinder, total width of the cylinder, and height of the base of the cylinder to the midpoint of the cuboid. Distance also from the base of the cylinder to the very top of the cuboid, and also the radius of my cylinder from the plan view. If I deleted that, I can put it back again by using annotate tab. From the annotate tab, there's a little icon here for dimensioning circles. If you select that and select the circle that you want to label, it automatically appears, and it is in the color this is the color of the layer that was selected. I can just switch it to dimension to get it to be the correct layer and the correct color. Alright, so important things that must be on your drawing for it to be considered a completed drawing. You must have your label, meaning your title here. You must have certain dimensions that are important to understanding the shape and dimensions of the object, like height, width from different angles, radius of a circle, length of this section. That part I did not add, I didn't know, to show you how that is done. For example, from the end of the cuboid to the first part of the intersection can now be placed in the drawing, and that should also be placed to the correct layer, so it should be showing peach or not green, and there you go. And also labeling of the intersecting points, meaning line 1 and 1A, 2 and 2A, 3 and 3A, and then the same thing goes for all views, in addition to labeling of A, B, C, D to show the 4 points or 4 main points of the cylinder. Now if you choose to use a different shape in your project, you may need to follow the same sequence. Every object, every solid is a different scenario, so you may need to use some reasoning to figure out how your number sequence will work and what points will connect and what points will not.